Section 1-1, Understanding Points, Lines, and Planes. The objective of this lesson will be to identify, name, and draw points, lines, segments, rays, and planes, and to apply basic facts about points, lines, and planes. Now, at about 300 BC, a man named Euclid decided that there needed to be some order to all the geometry that was happening or being created around him. He said that all geometry stemmed off of these three undefined terms. And the reason he called them undefined terms are because they're the three most basic figures in geometry that cannot be defined using any other figure. The first one is a point. A point names a location and has no size. It is represented by a dot. And when we put a point, we normally put a letter next to it so that we know which point we're referring to. The second one is a line. A line is a straight path that has no thickness and extends on forever. And we represent that by drawing a line with arrows on each side so we know it goes on forever. The third one is a plane. A plane is a flat surface that has no thickness and extends forever. So here we represent a plane by drawing a quadrilateral. Okay, the next two slides are going to cover some vocabulary that we're going to encounter in this next chapter. Make sure you are familiar with them because they will be used also throughout the unit and the rest of the school year. First one, we have collinear. Collinear are points that lie on the same line. So for example, here we have points K, L, and M. These 3 points are said to be collinear because they lie on the same line. Coplanar are points that lie in the same plane. We've got 3 points here, and they lie on the same plane. You can think of a plane as your sheet of paper. If you draw 3 random points, if they're on the same sheet of paper, then you could say they are coplanar. A segment or line segment is a part of a line consisting of 2 points and all points between them. So remember, a line extends on forever, but if you were to cut a piece off of that line, that is considered a segment. An endpoint is the point at one end of a segment or the starting point of a ray. So endpoint is exactly what it sounds like. It is a point at the end, endpoints. A ray is a part of line that starts at an endpoint and extends forever in one direction. So it starts at an endpoint and it extends on forever in one direction. Opposite rays are 2 rays that have a common endpoint and form a line. So they have a common endpoint, in this case it would be E, and one ray goes to the right, the other ray goes to the left, and they form a line. Okay, a postulate. This is a statement that is accepted as true without proof, and they are also called axioms. Later on, when we get into geometry a little bit more with proofs, you will realize that anytime you want to create something or say that something's true, you need to be able to justify it and explain why something is true. For a postulate, just like an undefined term, this is something that we accept as true. We don't need to prove it because no matter what, it's always going to be true. The first postulate says, through any 2 points, there is exactly one line. So if you were to draw 2 random points on your sheet of paper, then there would be only one line that could go through both of those points. The second one says, through any 3 non-collinear points, there is exactly one plane containing them. So if you randomly draw 3 points, only one plane could have all those 3 points on it. The third one says, if 2 points lie in a plane, then the line containing those points lies in the plane. So this one says, if you've got 2 points that you draw on a sheet of paper, and if you draw a line connecting those 2 points, then that line has to be on that plane, on that paper where you drew it. Okay, the fourth postulate says, if 2 lines intersect, then they intersect in exactly one point. So what they're saying is, if you have 2 lines and they intersect means cross each other, then they intersect at exactly one point. This is the only place where they will touch. No matter how far this line goes and this line goes, they will never touch each other again. The fifth postulate says, if 2 planes intersect, then they intersect in exactly one line. Now this one's kind of hard to draw, so I'm going to have you look around your room, and let's say each one of your walls could represent a plane. Now if one of your walls touches another one of your walls, when they touch, if you look, it creates a line. Just look up and down. That is the corner of your room. When those two walls intersect, they create a line. And that is the only place that they will touch. There's no way those planes will touch anywhere else. Okay, now let's work through some examples. For this one, it says, use the figure to name each of the following. We're going to name 5 points. Now, to name a point, we just use the letter that's next to that point. So this right here is called point A, and we just put the letter. I see point B. There's also point D and point E. So we separate each one by a comma. Now we need one more. I don't see any other black dots. But if we remember, one of our postulates says if two lines intersect, then they intersect at exactly 1 point. So even though there's not a big black dot here, does not mean that there's not a point here. So we have point C. Number 2, name 2 lines. If we look at this line, we see that there's 2 points on this line. And to name a line, we need 2 points. So we're going to name this line, line AC. And you'll notice that when you represent a line, we put a line symbol on top of it so that we know it's a line. If it's a ray, we'll put a ray symbol. If it's a segment, we put a segment symbol, but we'll get to those in the later sections. Another line is right here. Now this line has 3 points, but I only need 2 points to name this line. So you can choose any 2 letters here that you want. I'm going to choose B and D, so I'm going to call it line BD. Number 3, 2 planes. We have 2 planes. There's this blue plane and then there's the peach looking plane. If you notice in the corner of each plane there's a fancy written letter. That is how they name each plane. So this plane right here is called plane F, and the blue plane is called plane N. N is down here. For the 4th one, name a point on line BD. Well, here's line BD. There's 3 points on him. I can choose point B, point C, or point D. It doesn't matter. It just wants 1 point. So I'm going to choose point C. Okay, number 5, it says use the figure to name each of the following. A line that contains A and C. So we need to name a line that contains points A and point C. Remember, this creates a point here. Well, we've got 3 points, and to name a line, I only need 2 of them. And I'm just going to go ahead and call it line BC. For number 6, a plane that contains points A, D, and C. This plane right here contains points A, D, and C. So it's plane M. For this one, use the figure to name each of the following. Number 7, 3 collinear points. Remember, collinear means points that are on the same line. Okay, well, I need 3 points that are on the same line. On this line, there's only 2. Remember, this is a point. And on this line, here are our 3 collinear points. We've got point A, point B, and point E. Number 8, name 4 coplanar points. Coplanar, if you remember, are points that are on the same plane. Well, all of these points are on the same plane, so I can name any 4 of them. We've got point A, point B, point C, and point D. Remember, it's points on the same plane, so it doesn't matter that D is not on the line. Number 9, a plane containing E. Well, this plane right here is containing all the points, and E is on it, and the name of this plane is S. And remember, if you have any questions, try going back through the video and seeing if you can clarify them yourself, or come to class prepared to ask the questions at the beginning of class.